We've seen how alternate explanations are the main issue to think about when you get an argument that goes from correlation to cause. If you want to weaken the argument, bring up a potential alternate explanation, and if you want to strengthen an argument, get rid of an alternate explanation. But there are other ways to affect this kind of argument. One of those ways is by strengthening or weakening the correlation itself. Here's what I mean. Let's say the premise establishes that during a study, scientists found a correlation between taking fish oil supplements and performance on a test of memory. What that means is that if you were to plot the amount of fish oil that different people took with those people's performance on the test, you could draw a general trend line that would have a positive direction. This is what is meant by saying that there's a correlation. But in this particular pattern of dots, if I didn't draw this line, it might be really hard to tell that there is even a positive association between these two things. This is an example of a weak correlation. It's still a correlation, and it's still some evidence of a cause, but it's just not that strong. What if instead the data points looked like this? Here the trend line is very obvious, and the relationship between more fish oil and better performance is clear. Which data set provides better evidence of a causal relationship between taking the fish oil and performance on the memory test? I think you'll agree that the second one does. And that's because if there really were a causal relationship between fish oil and memory, you would expect to find a pattern that looks more like the second example than the first. In the first example, the correlation is so weak that it almost looks like this pattern could have been produced by random chance. But in the second example, this pattern is highly unlikely to be the product of chance. Now, this doesn't mean that there is guaranteed to be a causal relationship, but it does create a stronger suspicion that there is one. And that's why strengthening a correlation does strengthen a causal argument. When an argument starts off with a correlation in the premise, all that it's saying is that there's a general trend line that you could draw for the data. But we don't know whether the line is a loose fit to the data or whether it's a very tight fit. An answer that helps establish that the data looks more like the tight fit example provides better evidence of cause. That kind of answer might sound something like this. In the study, there was a proportional relationship between amount of fish oil consumed and performance on the memory test. Or it might sound like this. In the study, the more fish oil participants ate, the better their performance on the test. These kinds of answers are showing that the data looks more like this. Another kind of answer that could strengthen this argument is one that shows that the correlation holds in other contexts. Right now, the argument's premise indicates that the correlation was found in this study. But it's possible that the people in the study might be unrepresentative of people generally. Maybe there's some reason that fish oil affects these people differently, and if you were to broaden the study to include millions more people, it might turn out that there's no correlation at all, or maybe even a negative correlation. So it would help the argument to learn, for example, that this correlation has been found among another broader group. There's another kind of answer that could strengthen this argument, and this one relates to the extremes. Let's say we find out that the people who took the most fish oil supplements got the highest scores on the memory test. This at least shows that the trend line fits very tightly at the top. And that's why it does strengthen this argument. However, you do have to be careful because if you just change this answer slightly and say that some people who took lots of fish oil had very high scores, suddenly this would not strengthen, because this answer doesn't say anything about whether the trend line at the top is loose or tight. That's because when you have a lot of data points, there are bound to be some people who took fish oil with high scores, regardless of how strong this correlation is. Simply pointing out that there are some examples of people who took fish oil with very high scores doesn't really add anything to the general idea that there's a correlation. It's not actually making this correlation stronger. So to boil all of this down into some practical advice, when you're thinking about how to strengthen an argument that goes from correlation to cause, Answers that show that the more of the cause is connected to more of the effect, or that the less of the cause is connected to less of the effect, will strengthen because they're showing that the correlation is stronger, that the trend line is a tighter fit to the data. And on the flip side, if you want to weaken the argument, you can do so with answers that show that the more of the purported cause, the less of the purported effect, or that the less of the purported cause, the greater the effect. These answers are inconsistent with a strong correlation. They show that the correlation is weaker than you might initially think, or that you actually start to have a negative correlation in some cases. At all times, however, you have to be careful about answers that are just about a few individual cases. Remember, a correlation is just a general trend. It's a statistical average. It already allows for there to be some exceptions that don't follow the trend. So unless the conclusion says everyone who has the cause will have the effect, pointing out that there are some exceptions that don't have the effect just doesn't matter to the argument.